Hello, welcome to our activity on building fraction and decimal concepts. In this 20-minute activity, we're going to take a look at how fractions were developed in various cultures over thousands of years to the mathematical concepts we use today. It will help you to understand how to solve problems in the GRE that deal with ratio, percentages, fractions, work problems, anything basically that involves some sort of division will come out of this module itself. And you'll walk in with the starting value of 130, everyone starts there, and this module alone will be able to boost you up to a score of 141. It locks those first 11 points in, and then it forms the foundation for all the rest of the modules we're going to take a look at, all the way up to the goal of getting that complete perfect score of 170. What you'll need is a quiet area and your worksheet, the building fractions and decimal concepts, and the key. We'll take a look at that at the end. Pen and pencil, colors are nice but not required, and if you like to keep things neat, a straight edge is helpful. So remember, doing this activity in a mindful, concentrated way is working to get your left and right side of your brain to work together, to find out within yourself how you understand fractions and how you can take a concept and look at it in a way that makes it personal for you, easier for you to work with, and building your success, building that strong foundation for the rest of the activities we'll do. We'll follow this one up directly with some GRE problems that involve fractions and decimals, and we'll see how this activity really empowers our ability for success. So let's get started. Okay, so here we have our worksheet. We started off as humans counting by 1, 2, 3, 4, whole things, we counted them. But we also, as we built into societies, we found the need to share, to divide what we had into smaller pieces. And so there was 3 ways that we basically have come up with that are still in use today for deciding on how to make fractions. The first one over here that we'll take a look at is dividing things in half, because we found out as humans we were pretty good at just taking things and eyeballing it, cutting it in half. So let's see how we do here. I'm going to take this first piece, and if we want to think of this as a fraction, what is this? This is one piece out of one piece. It's a whole, or we list it as 1.0. To get our divisions, what we do is we take this whole and we cut it in half. And we'll eyeball it, I think about there will do. Cut that in half. And what we have is we have 2 pieces, but we don't think of them as 2 whole pieces. We think of them as 1 out of 2 pieces and 2 out of 2 pieces. 1 half and 2 halves. We continue building on this concept by cutting the half in half. And so again, we eyeball it here, and it looks like to me this will be at about equally dividing it into 2 pieces. And up here, maybe about there. What do you think? Do the best you can. And we should have 4 equal pieces. And again, we name them and we count them. 1/4, 2/4, 3/4, and 4/4. We're continuing along with this process. We're going to take each of these fourths and divide them in half. So let's see if I can eyeball it here again. Cut this one in half. Cut this one in half. Divide this in half. And then let's divide this in half. And notice we have 8 pieces now. And we'll label them by their names, by counting. We've got 1/8. We've got 2/8. 3/8. So notice now fractions aren't so difficult. They're just like counting whole numbers. 4/8, 5/8, 6/8, 7/8, and 8/8. Very good. Now the last step in this process, or not really the last, but the last we're going to take a look at, is to take each one of these 8s and divide them in half. I know it might seem a little tedious, but you're going to see something. When I did this activity for the first time, I started to notice some things as well. We'll talk about those in a moment, but I want you to focus just on dividing everything in half. That's all we're doing. That's all a fraction is to take it, divide it in half. Share it with a friend. So think of fractions as a friendly activity of division. Physically we're dividing, and then what we're left with are fractions. 1/16, because there's 16 pieces here now. 2/16, 3/16, and we keep on counting. 4/16, just take your time, let it all sink in. 5/16, and you'll be amazed at how this will empower your ability to work with fractions. Which again, from my experience, is one of the most difficult tasks that students have. If people have problems with math, usually it means they have problems with fractions. Not always. I mean, there's some people who move on, they're okay with fractions, but they have some issues with some other part of math. But I'll tell you what, see, mindfulness, you got to keep counting. 9 goes to 10, 16ths, 11/16, 12/16. And what's next? 13/16, 14/16, 15/16, followed by 16/16. Now we could come back here, and you'll see it's on the answer key, but you could take each of these fractions and turn them into a decimal. This is just a different way of writing the same thing. So what does 1/2 become? 1 divided by 2 gives us 0.5. 2 divided by 2 gives us 1.0. So notice when we have all the pieces, we have 1. This is a very important concept. 1 is the completion. It's also going to see later on it's 100%. 1 is 100%. It's everything we've got. Then you can come down and take the force. 1 divided by 4 gives you 0.25. And one of the techniques I'll show you, 2 divided by 4 is 0.5, is we can use our calculator to come up with decimal answers, but oftentimes we need to connect them back to the fractions. And by working through this activity, we're going to be able to do that. And we see that 0.5 and 0.5 are the same. So yes, 1/2 and 2/4 are equivalent. They're the same amount. 3 divided by 4, 0.75. 4 divided by 4, 1.0. Notice when we have everything, we've got 1.0. We'll just do the 8ths, and then the 16ths are already on the answer sheet. But 1/8, take 1 divided by 8, and you'll get 0.125. 2 divided by 8 gives us 0.25, equivalent to 1/4. 3 divided by 8 is 0.3. Let me check my numbers. I'm 7.5. I used to be a mortgage loan processor, so what you find is mortgage loans are based on percentages by an 8, so you get these decimals down pretty good, but it's been a long time. 4 divided by 8, 0.5. So we see that equivalency. 5 divided by 8, 0.625. 6 divided by 8, gives us the 0.75, equivalent with 3/4. 7 divided by 8, 0.875, and 8 divided by 8, 1.0. So that's the first system of dividing things, just to cut things in half, cut them in half, cut them in half again. There's a whole mathematics that's been used around the world. One's called Russian peasant math. The Egyptians use this method of either halving or doubling. It's a good concept to have down. But let's now move forward to another system which was based on cutting things into thirds. So again, we start off with a whole, 1 out of 1, which is 1.0. But instead of cutting things in half, what we're going to do is cut them in thirds, because humans are actually fairly good at cutting things in thirds. So let's see what happens when we do that. Let's see. Here we go. Here's a third. And then I'm just going to eyeball it. It's, I think, about here. To try to get equal thirds, we'll go there. And again, we've got 3 equal pieces, and we'll label them as 1/3, 2/3, and 3/3. Now, what's interesting here is that we could continue cutting each of the thirds into thirds, and we'd have ninths, but that doesn't seem to be a system that was widely used. What most people did, most cultures, is they continued on with the first method. It's sort of a hybrid. They took the thirds and they cut them in halves. So watch what happens when we do this. Take a third and now cut it in half. Take this 2/3, let's cut that in half. And then take this 3/3 and let's cut this in half. And I'm a little bit off, but if these were all equally spaced, each one is 1/6 of the whole. So we'll start counting. 1/6 is the first piece. 2/6 is the second piece. 3/6 is the third piece. The fourth piece is 4/6. 5/6, and 6/6. And again, the last step in this process was to take each of the sixths and divide them in half. And so we'll go ahead and continue on here. You kind of start seeing what's happening here. How many pieces are we going to get? Yes, 12 pieces. But we'll carefully try to cut each of these in half. Use your artistic skills, and you'll find that sometimes the people who are really good at math aren't as good at the drawing part of this as others. So I find that the artistic nature of some people is just spatial artistic, spatial mathematics might be your strength. As you can tell, I could use a little work on it. So what we now have is we've taken each six divided it in half, so we have 12 pieces. We could count them, and let's do that. We've got 1/12. We've got 2/12. We've got 3/12. We've got 4/12. We've got 5/12. We've got 6/12, which is the same as 3/6, which you kind of look over here is the same as a half. So we've got this connection between the halving method and the dividing by thirds and then dividing in halves. Let's keep going. 7/12, 8/12, 9/12, 10/12, 11/12, and finally 12/12. We were right, there are 12 pieces. And again, we can go through and turn these into fractions or to decimals. So 1 divided by 3 gives us our 0.3 with a lot of 3's after that, the 3 repeating. So we put a little bar over the top to indicate that the 3's continue to repeat. 2/3 gives us 2 divided by 3. We get 0.6 repeating. We'll do it like that. Sometimes we round this to 0.67. However, that is an approximation. We have rounded. 3 divided by 3, whenever we get back to a whole, we now have a nice terminating number, 1.0. And the 6 are a little bit different. You'll take 1 divided by 6 and you'll see you'll get 0.16, and the 6's repeat. And then we get, here we are, 2 6, which is the same as 1/3, so that's going to give us 0.3, and the 3 will repeat. 3 6 is a non-repeating decimal because it's simply 0.5. It's the same as 1/2. 4 6 is going to be the same as 2/3, so that's 0.6 repeating. 5 6 is going to give us 0.83 with the 3 repeating, and then 6 divided by 6 gives us back to our 1.0. And then later on the answer key, we'll look up the decimal equivalents for the 12ths to see how that works. But we have a special privilege, I guess, if you've used the British system of measuring things, which is now really the American system of measuring things in ounces and inches and feet. You'll notice that in this system we take a foot and we divide it into 12 inches. That's the second method that's being used. Each of those could be considered an inch. But when you look at a ruler, they don't take each inch and then divide that into 12 pieces. No, they divide it into 16 pieces. So we have a 1/16 of an inch, 5/16 of an inch. It's a combination of these two systems. And I challenge you to look in your refrigerator at your drinks and the cans and the bottles, and you'll see that you've got some things that are 12 ounces, some things that are 16 ounces. Or we'll see some that are using the last measurement system, which is a metric system, and we'll see how that develops for us. But you'll start to see that this was really the only fractions that were pretty much used. So the last system, this comes from India and other areas we'll see, but it's the basis of our current decimal math system. So let's get on to that. We've got, again, this last one, we start out with one whole. So we've got 1 out of 1, 1.0. And then what they found is we've got a system that divides in half, one that divides into thirds. Notice the 4's come from first dividing in half, and then 6 comes from dividing the thirds in halves. So the one thing that we haven't been able to do is to divide things into 5 pieces. And we find that that is about at the limits of a human's natural ability. Some of you could probably divide things evenly into 7 pieces, but that's your prodigies. I have a difficult time with that. But let's try this, dividing it into 5 pieces. So I'll come along here, and there's one. We're trying to divide it into 5 equal pieces, which means we're going to cut it 4 times to get 5 pieces. 4 cuts gives us 5 individual pieces. Let's see here. How did we do? So there's 5 pieces, 1, 2, 3, 4, 5, and they're relatively close to being even. So again, we've got 1/5. We've got 2/5. We've got 3/5. We've got 4/5. And we've got a complete, again, 5 out of 5 pieces. Now what was done next is, instead of cutting each of these into 5 pieces, which could be done, and you do have systems that sort of do that, you know, bundling things by 25, but the more standard thing was to do is to take this and divide each of the fifths in half. Because that was kind of a challenge, at least for me it was, to divide into fifths. But taking each of these fifths and cutting them in half is back to kind of like, oh, this feels nice and natural. Just kind of eyeball it, that's about half. We'll cut it, and that's about half. And what we end up is we've got now 10 pieces, and we'll label them 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. Notice the even and odds. The evens are matching up with the fifths, but the odds don't. They're kind of halfway in between. 6, what are we now? 7/10, 8/10, 9/10, and 10/10. And again, it's helpful if you need to take your calculator on these, but let's take each of these fractions and turn them into a decimal. So we've got 1/5. 1 divided by 5 is going to be 0.2. 2 divided by 5 is 0.4. 3 divided by 5, 0.6. 4 divided by 5, 0.8. 5 divided by 5, we're back to a whole, 1.0. And the tenths are based on our decimal system, really easy. 1 divided by 10, 0.1. 2 divided by 10, 0.2, equivalent to 1/5. 3 divided by 10, 0.3. 4 divided by 10, 0.4. 5 divided by 10, 0.5. 0.6. 0.7. 0.8. 0.9. And finally, we're at 10. We cover over to 1.0. Now there was 2 paths that we could go from here. In India, what they did is they took each of these tenths and they broke them down into 10 pieces. So then you'd have hundreds. And this is the whole basis for the modern decimal system that we use today. Discovered, invented, used at least by the Indian culture 3,000 to 5,000 years ago. The modern metric system is based on this. But there's another cultural aspect that we could do, is if we took each of these tenths and divided them in half, what would we find? We would find that we now have 20 pieces. And the cultures of the Mayans, the Aztecs, and even the French, this is interesting, over in Europe, the French have their mathematical system based on completion to 20. Look at the French language. The word for 80 is literally 4 20s. And the same sort of system developed here in the Americas, in South Central Mexico, and down into Central America as well, by the Mayans and the Aztecs and others. But we're going to focus on the use of these 3 systems because the modern mathematics we use today that are used on the GRE are based on these. So what we want to do is take a look at the answer key. And let's look for a few patterns. I need to save this, we'll just pull to here. So now what we want to look at is what's kind of interesting to do is to see when we've got a whole, it's always 1.0. 100%, 1.0. However you cut it, when we've got all the pieces, 6 out of 6 pieces, we've got 1.0. 5 out of 5 is 1.0. And when 2 fractions are equivalent, when they are the same amount, let's just pick out here. This one here could be called 2/3, or it could be called 4/6, or it could be called 8/12. All of those are equivalent, and what we see is that their decimal representations are the same. So this is going to be a valuable way to just kind of take a look at how the fractions are related to the decimals and the decimals are related to the fractions. Most of the work we're going to do within the GRE involves these fractions. Now occasionally they throw in a 1/7 or a 1/9 just to make things interesting, but what we'll work with those is we will turn those into their decimal equivalents and be able to do just fine with them. But take a look at this pattern and see how it works and see